Hello and welcome to my channel. In this video we are going to solve some exam questions from the chapter 2 Quadratics from International Advanced Level Pure Mathematics 1 with a subject code WMA1101 from January 2019 to January 2020 question paper. So let us start with the first one. The equation 3 over x plus 5 is equal to minus 2x plus c, where c is a constant and has no real roots. Find the range of possible values of c. So here you can see that we have a fraction, that is 3 over x. So first thing is we will try to get rid of that fraction by multiplying the entire term with x. So here x multiplies with 3 over x, so we get 3 over x times x plus 5 multiplies with x, so we get 5x equals minus 2x multiplies with x, giving us minus 2x squared, and plus c multiplies with x, giving us plus cx. We can cancel the x in the denominator and x in the numerator, and now we are left with 3 plus 5x equals minus 2x square plus cx. Now this is somewhat like a quadratic expression now, because we have x square and we have x and also we have a constant. Now since x square is a negative term, I will take the right hand side towards the left hand side, the entire term, to make this x square positive. And rearranging it, we get it as positive 2x square plus 5x minus cx plus 3 is equal to 0. Next, here we can write it as 2x square plus, these two are like terms, so I can factorize it and take out the x common out. So 5 minus c remains in the bracket plus 3 equal to 0. Now if we compare this with the format of the quadratic equation, it is as ax square plus bx plus c equal to 0. So by comparison we can say that a is equal to 2 and b is equal to 5 minus c and c is equal to 3. This is what we get. Now remember that this c and this c is not same. This c is a constant they have given, we haven't yet found out that. Now they have said that the given expression has no real roots. Now if this is mentioned, there is a condition for the discriminant given as b square minus 4ac has to be less than 0 because it has no real roots. So for that, this is the condition to be followed for the discriminant. Now we can see that we have got b as 5 minus c. So in place of b square, we will substitute it as 5 minus c the whole square minus 4 times a we have it as 2 and c we have here as 3. So this has to be, let us for time being take it as equal to 0. Now next we can get it as 5 minus c the whole term squared minus 4 2s are 8, 8 3 times is 24, so we get it as 24 equal to 0. So rearranging it further, we can write it as 5 minus c the whole squared is equal to 24. Now I am transferring the square on the other side, so it becomes 5 minus c is equal to plus or minus square root of 24. So remember, when square goes on the other side of equal to sign, it turns into plus minus square root. Now we have 5 minus c equal to plus or minus, let us check how much is square root of 24. So it gives us as 2 root 6. So plus minus 2 root 6. Hence we can write, we will take minus c on this side and we'll take plus minus 2 root 6 on the other side. So we get c is equal to 5 plus or minus of 2 root 6. So this term is transferred over here and minus c is transferred over here. So this is what we get. Now they have asked us to write the range for all possible values of c. So we can write it as 5 minus 2 root 6 is less than c is less than 5 plus 2 root 6. So the given range is from 5 minus 2 root 6 to 5 plus 2 root 6. And it is less than because the condition says b square minus 4ac has to be less than 0 if it has no real roots. Hence we write it this way. So this is the given range for c. Now let us look at the next question from International Advanced Level Pure Mathematics 1, May 2019 question paper. Find using algebra all real solutions of 2x cube plus 3x square minus 35x equal to 0. So we can see that the x term is common from all the three terms. So we are going to take the x term common out first and write it as 2x square plus 3x minus 35 equal to 0. So we have two factors here now. One is x equal to 0 and another one is 2x square plus 3x minus 35 equal to 0. We have to further factorize this using either of one of the methods, that is splitting the middle term or using the quadratic formula or by completing the square method. I will be using the quadratic formula over here, which can be written as x is equal to minus b plus minus square root of b square minus 4ac over 2a. So this is the quadratic formula which can be used to find the factors of the given expression. Now we can write the a here as the first coefficient of x, which is 2, and b is going to be plus 3 and c is going to be minus 35. So using these values and substituting in this formula, we get x is equal to minus 3 plus minus square root of 3 square minus 4 times 2 times minus 35 over 2 times 2. So here we have minus 3 plus minus, let us check how much we get the term inside the square root. So we have it as square root of 3 squared minus 4 times 2 times minus 35. So we get it as 17. So we have here as 17 over 2 times 2 is 4. So further solving this, we get it as one of the factors is minus 3 minus 17 over 4 and another factor is x equal to minus 3 plus 17 over 4. So we have here x value as minus 20 over 4, which is going to give you x equal to minus 5, and here we have x is equal to 14 over 4, or we have it as x equal to 7 over 2, or we can also write it as 3.5. So we have got in total here 3 values of x, that is x equal to 0, and we have x equal to minus 5 and x equal to 3.5. So these are the 3 values of x. Now let us look at part B of the question. Hence find all real solutions of 2 y minus 5 whole raised to 6 plus 3 times y minus 5 whole raised to 4 minus 35 y minus 5 whole squared equal to 0. Now if you observe carefully, this equation and this equation are almost same, because the coefficient of x cube is same as coefficient of y minus 5 raised to 6. Coefficient of x square, which is 3, is same as coefficient of y minus 5 raised to 4. And coefficient of x, which is minus 35, is same as coefficient of y minus 5 the whole square. So if we see there is a kind of pattern over here, the easiest way we can solve this is by just taking the last term of the above expression and equate it to the last expression of the below equation. Make sure that the smallest power of x is equal to the smallest power of y expression. So let me write it here as minus 35x is equal to minus 35 y minus 5, so y minus 5 the whole squared. So the smallest power of x I have equated it to smallest power of y. I'm going to cancel out the minus 35 and minus 35 from both the sides and write the above expression as x equal to y minus 5 the whole squared. Now since we have to find out the values of y in part B, we have to find all the real solutions of y, we are going to make y as the subject in this case. So I'm going to send the square on the other side, so it becomes plus or minus square root of x equals y minus 5. Next I'm going to send the minus 5 on the other side, so the expression becomes y equals 5 plus or minus square root of x. This is what we have to get the expression for y in terms of x. Now as you remember, we have already got the values of x in the above part A as 0, negative 5 and 3.5. So we have to simply equate it in this expression and get the values of y. So let us see what we get when x is equal to 0. So when x is equal to 0, y will be equal to 5 plus or minus square root of 0, which ends up as only 5. So this is the first value of y. Next let us take when x is equal to minus 5. Now we have it as y equals 5 plus or minus square root of minus 5, and square root of any negative number does not exist. That's why we have to write no solution in this case. So if you put in your calculator this expression, it will show you an error, syntax error. So there is no solution whenever there is a square root of a negative number. Finally we have when x is equal to 3.5. So we can write y is equal to 5 plus or minus square root of 3.5. So we get it as 5 plus, let us check for square root of 3.5. We get it as 6.87. If we take the plus value, it's only for plus, and for the minus, let us see what we get. 5 minus square root of 3.5. So 5 minus square root of 3.5. We get it as 3.129 or 3.13. So you can either write the answer in this format or you can change it to decimal. So both are acceptable values, and hence the values of y are plus 5. There is no solution for this, and there are two solutions for x equal to 3.5. So this is how we solve the given question. Let us look at the next question, which is from the same question paper, that is May 2019. It is the 6th question. So in May 2019 there were 2 questions on quadratics, and this question is a combination of straight line graphs chapter and quadratic equations. So let us see how to solve this question. The line with equation y equal to 4x plus c, where c is a constant, meets the curve with equation y equal to x times x minus 3 at only one point. Find the value of c. So in such questions, if you see the terms or words like meets the curve, then we have to see that the equation of the line y of line is equal to y of the curve. So wherever there are words like intersects or find the points of intersection or meets the curve, line meets the curve, so look for these wordings. So these means that we have to equate both the equations. So here equation of the line is y equal to 4x plus c. So here I will write it as 4x plus c is equal to equation of the curve, which is given as x minus 3. So I am going to just simplify this given expression further as opening up the brackets, that is x square minus 3x. Now I am going to take the left hand side towards the right hand side, so it becomes a proper quadratic expression. So it becomes x square minus 3x minus 4x minus c is equal to 0. So we have here as x square. These both are like terms, so we just add them up and write it as minus 7x minus c is equal to 0. Once we get this, we are going to compare it to the quadratic format, which is ax square plus bx plus c is equal to 0. So by comparison, we can say a is equal to, if there are no coefficients here, we take it as default 1. So a is 1, b is negative 7, and c is equal to negative c. Now after this, the condition they have given here is it meets at only one point. That means the curve and the line, if I'm going to draw a curve like this and there is a line passing right through it, they both just meet at one point. They have just one x coordinate. For this, we have the condition of the discriminant given as b square minus 4ac is equal to 0. So this is the condition where the two roots are equal or there is only one meeting point for the given curves or given curve and a line. Now substituting the values of a, b and c in the given discriminant formula, we get it as b square is negative 7, so negative 7 square minus 4 times 1 times c was negative c. So negative c equal to 0. So solving this further, we get this as 49 and minus of minus becomes plus 4c is equal to 0, or 4c is equal to negative 49 and c will be equal to negative 49 divided by 4. So let us see how much we get negative 49 over 4. So we have here as negative 49 divided by 4 gives us minus 12.25. So the value of c is minus 12.25. This is how we solve the first question, that is finding the value of c. Next, they have asked us, hence find the coordinates of the points of intersection. Now once we get the value of c, we are going to substitute that value of c in the expression we have got over here when the equation of line was equal to equation of the curve, because they want us to find the points of intersection. So let us just substitute the value of c there and we get it as x square minus 7x minus of minus 12.25 equal to 0. Let us further simplify this and write it as x square minus 7x, and minus of minus is plus 12.25. Now we have to factorize this given expression using one of the three methods. That is, first one can be by splitting the middle term, or the second method is using the quadratic formula, or the third method is by completing the square. I'm going to use here the quadratic formula because that is much easier and faster here. So x is equal to minus b plus minus square root of b square minus 4ac over 2a. So this is the formula for quadratics. Now here we have a is equal to 1, which is the coefficient of x square. We have b is equal to negative 7, which is the coefficient of x, and c, which is a constant, we have got it as 12.25. So substitute all of these values in this given formula and we get it here as negative of negative 7 plus minus square root of b square is minus 7 the whole square minus 4 times a is 1 and c is 12.25 divided by 2 times a is 1. So here it becomes minus of minus is plus, so plus 7 plus minus, let us check how much is the square root value going to be. So square root of minus 7 square is 49 and minus 4 times 1 times 12.25. So that gives us 0. So the square root is become 0 over 2. So we have just one value of x, that is 7 over 2, or x is equal to 3.5. So this is the value of x where the curve and the line meet each other. But they have asked us to find the coordinates of the point of intersection. So whenever the coordinates are mentioned, we are supposed to find the x as well as a y value. Right now we got the value of x as 3.5. So either we can use the equation of line to find out the value of y, or equation of the curve to find out the value of y. So here I am going to use the equation of the curve, that is y equal to x times x minus 3. So we will use equation of the curve, that is x times x minus 3, and I'm going to substitute it over here, that is 3.5 times 3.5 minus 3. So we get here the answer would be 3.5 times 3.5 minus 3. So we get it as 7 over 4. So it is 7 over 4 or 1.75. So we have here as x comma y as 3.5 comma 1.75. So these are the coordinates where the line and the curve meets. And this is how we solve the given question. Now let us look at the next question from October 2019. Solve using algebra the equation x minus 6x to the power of half plus 4 equal to 0, and fully simplify your answers, writing them in the form a plus b radical c, where a, b and c are integers to be found. Now to solve this, what we can do is, this is a term which is a bit different, that is, we can see the power of x is a fraction. So I'm going to take this entire term on this side of the equation. So we get it as x plus 4 is equal to 6x to the power of half. So negative 6 x to the power of half becomes positive 6x to the power of half. Now after this I will take the 6 on the other side, so that it becomes x to the power of half is equal to x plus 4 divided by 6. Now as we can see, there is a fractional power, so to get rid of the fractional power, either we can square on both the sides, so we can use this method, or simply we can send the power of half on the other side so that it becomes a square. So both the methods are acceptable. So here we can see x to the power of half multiplies with the power 2. So 2 and 2 cancels and we are left with x is equal to, this becomes x plus 4 to the power of 2 over 6 to the power of 2. So using the laws of indices, you can separate the powers to the numerator and to the denominator. After this, we will start solving the equation. So x equals x plus 4 to the power of 2, you can write it as x plus 4 times x plus 4 over 6 square is 36. Now next step is, I will take the 36 on the side and multiply with the x. So it becomes 36x is equal to, now I am going to expand the brackets. So x times x is x square plus x times 4 is 4x and plus 4 times x is plus 4x and 4 times 4 is 16. Further solving this, 36x is equal to x square, and these two are like terms, so we can add them up. So 4x plus 4x gives us 8x plus 16. Now let us take the 36x on this side so that all the terms are on one side of the equation. So we get x square minus 36x plus 8x plus 16 is equal to 0. So this ends up as x square minus 28x plus 16 is equal to 0. So you can see that we have got the expression in the form of quadratic. So we can use the quadratic formula to solve this given expression. The quadratic formula is given as x is equal to negative b plus minus radical b square minus 4ac over 2a. And in this equation we have a is equal to 1 because a is the coefficient with x square and here it is 1. B is equal to negative 28 and c is equal to 16. I'm going to substitute the values of a, b and c in this above formula and get it as x is equal to negative of negative 28 plus minus square root of negative 28 square minus 4 times a is 1 and c is 16 over 2 times a is again 1. So let us see, this becomes x equal to minus of minus becomes plus 28 plus minus, let us check what we get under the square root. So it is square root of minus 28 square minus 4 times 1 times 16. So we get it as 12 root 5. So it is plus minus 12 root 5 over 2. Now we can see that we can take the 2 common out from these two terms. So 2, let us take it common out, and here we get it as 2 14 times is 28 plus minus 2 6 times gives you 12. So 6 root 5 over 2. Now we can see the 2 in the denominator can be cancelled with 2 in the numerator. They both divide each other. And finally we get the answer as 14 plus minus 6 root 5. So they wanted us to get the answer in the format a plus b root c. So we will consider only the positive value over here and take it as 14 plus 6 root 5. And it was mentioned that a, b and c are integers. So a plus b root c, we can see that by comparison a is equal to 14, b is equal to 6 and c is equal to 5. So this is the answer for the given question. Now let us look at the next question from January 2020. Find using algebra all solutions of 20x cube minus 50x square minus 30x is equal to 0. That means we have to factorize this equation and get all the values of x. So let us start by taking the x common out from all these terms, and we can see that all the terms can be divided by 10 as well. So we can take 10x common out. So we are left with 2x square in the bracket minus 5x minus 3 is equal to 0. So we have factorized the given expression. Next we can separate out the factors as 10x is equal to 0 and 2x square minus 5x minus 3 is equal to 0. Now here we can see x becomes equal to 0 because 10 goes on the other side and 0 divided by 10 is 0 itself. So we got the first value of x, which is x equal to 0. Now let us start solving this quadratic equation using quadratic formula, which is given as x is equal to minus b plus minus square root of b square minus 4ac over 2a. As we know, a is the coefficient of the x square, so a is 2 here, and b is the coefficient of x, so it is negative 5, and c is the constant, so here it is negative 3. Now let us substitute these values of a, b and c in the above formula, and we get it as x is equal to minus of minus 5 plus minus square root of b square is minus 5 square minus 4 times a is 2 and c is minus 3. Whole thing divided by 2 times a, which is again 2. So here we get it as minus of minus 5 is plus 5 plus minus, let us see what we get the square root term here. So we have it here as square root of minus 5 square minus 4 times 2 times negative 3. So that gives us 7. So plus minus 7 divided by 2 times 2 is 4. So we have two values of x over here. One value is x is equal to 5 plus 7 over 4, and another value is x is equal to 5 minus 7 over 4. So here we get x equal to 12 over 4, which then divides and gives us x is equal to 3, and here we get x is equal to negative 2 over 4, which then simplifies and gives us x equal to negative 1 over 2. So the three values of x which we got here is x equal to 0 and x is equal to 3, and we got x equal to negative half. So these are the three values of x. So x is equal to 0, it is equal to 3, and it is equal to -1/2. So these are the three values of x. Now let us see how to solve the part B. Hence find all real solutions of the given expression. Now if you look carefully, these two expressions are almost same, because you are going to check the coefficients of the x terms with the y terms. So 20 and 20 here, -50 and -50 here, and -30 with -30 over here. So we can solve this question by comparing the smallest power of x with the smallest power of y. So here you can see the smallest power of x is 1, and here it is 3/5, which is nothing but 1.5. Here the power is 1, and here the power is 1/2, which is nothing but 0.5. So this is the smallest power of y, and this is the smallest power of x. So we can equate the smallest power of x with smallest power of y, or another way to look at it is you can compare the coefficients. Whichever coefficients of x matches with the coefficient of y, we are going to equate those terms. So here by comparison we can start solving this example. So -30 x is equal to -30 y, it was +3 to the power of half, y +3 to the power of half. So we have equated these two. Now since the coefficients are same on both the sides, we can cancel the coefficients, and the negatives also cancels from both the sides. So we are left with x is equal to y +3 to the power of half. So half becomes x to the power of 2/1. So the power flips. So 1/2 becomes 2/1 whenever you send the power on the other side of the equal to sign. This will be equal to y +3. So let me write this again. It becomes x square. I'm going to make y as the subject here, so I'll be sending +3 on the other side. So it becomes y equals x square -3. So this is what we have to get the expression, that is y in terms of x. Now in part A we had already got the values of x as 0, 3 and -1/2. So we are going to substitute one by one these values of x and get the values of y respectively. So let us first start with when x is equal to 0. We get y is equal to 0 square -3. That is substituting in this equation. So we get it as -3. This is the first value of y. Now let us take x is equal to, the next value we had got it was 3. So x is equal to 3. So we get y is equal to 3 square -3. So it is 9 minus 3, which is 6. And finally we have the value of x as -half. So let us substitute over here. Y is equal to -half square -3. So this becomes 1/4 minus 3, which is -11/4. Now we have to check which all are solutions of y. We need to cross verify by substituting the value of y, whichever we got, in the above expression, and check whether the left hand side is equal to 0 or not. So let us check the values of y, which we have got it as y is equal to -3, y is equal to 6, and y is equal to -11/4. So which all are the solutions of this equation. So when y is equal to -3, we can see that -3 plus 3 is 0. So this term becomes 0. Again here -3 plus 3 becomes the entire term is 0. And again y is -3 plus 3, this entire term becomes 0. So here left hand side is equal to right hand side. So y equal to minus 3 is a solution of the given expression. Now let us check when y is equal to 6 whether we get this entire expression as equal to 0 or not. So let us start substituting it. So 20 times it is 6 plus 3, which is 9, to the power of 3 over 2 is 1.5, and then we have minus 50. Then again we have 6 plus 3, which is 9, to the power of 1, and minus 30 times 9 to the power of 0.5. So we get it as 0. So when y is equal to 6, we get the left hand side is equal to the right hand side. So y is equal to 6 is also a solution. Now let us check minus 11 over 4 is a solution or not. So here let us substitute 20, and in the bracket we have negative 11 over 4 and plus 3 to the power of 1.5, and then we have minus 50. In the bracket we have again negative 11 over 4 plus 3 to the power of 1, and minus 30. We have again negative 11 over 4 plus 3 to the power of 0.5. You can see that we did not get the left hand side as 0 because we get it as negative 25 is equal to 0, which is not a solution. Hence we are not going to take negative 11 over 4 as a solution to this equation. So finally we have the values of y as, we are going to discard this. So y is going to be equal to negative 3 and 6. So this is how we have to solve the given expression.